Okay, everyone. I think it's time to start. And today's session will be about XNA on the Windows Phone 7 platform. And I'm going to be covering it from a pretty grounds-up fashion. But just to let you know, I do have some in-depth information available during this assembly. We have actual phone available. So if you have any, in-depth questions about something, please hang on those and come to me after the presentation. So just to let you know, there's a possibility for that. But for now, let's start with me. First off, I've been around in the gaming scene on a student perspective for quite some time. I just graduated from the TAMK, the Applied Sciences place near Tampere, and I've been involved with the Score Game Development Club, the first and the best at its time. I've been part of the IGDA coordinators gang for a few years. I was with Neo Games doing the Finnish Game Business '08 survey, and I've been dealing with the Nordic Game Conference as an advisory board member a few years back. And also, I'm of course a Microsoft student partner, which is why I'm involved in the whole Windows Phone thing. And actually, my history with XNA itself, this is what's all about. I've been dealing with it since the version 2, so it was like 3 years or something at this point. And I started on a hobby background, just to create some cool stuff, First, some little demo effects, a few games, interactive pieces, and then full games, mainly as student projects and whatnot. But on that perspective, I know some of the history of XNA. So what I'm about to tell you today, our agenda, will be mostly about the platform itself. I'm going to touch the hardware a bit, but those specifications, you can see them online, and there's really nothing special to them. So I'll tell you more about the platform, its possibilities, how to get started in a very grounds-up way, and some hints and tips on the marketplace itself, and maybe something on how to deal with the hardware, like how to use it to create games, awesome stuff. And hopefully we'll have a few awesome demos and whatnot. So if we start with XNA, what is it? XNA stands for XNA is not acronymed, so it doesn't mean anything. It's a framework built on top of .NET, so it's an extension to the Microsoft's widely used .NET framework for creating software, and it's specialized especially for making games. So in short, in real-life language, it's a bunch of cool stuff, so you can make better games faster, in a sense. And of course, there are loads of things that XNA is not. It's not an engine, for instance. So games created with XNA don't look like XNA games. Like, if you create some stuff with the Unreal Engine, you probably notice that there's the Unreal-ish kind of visuals to it and whatnot. XNA is more on the background level. Like we said, it uses .NET, so it's based around C# as a programming language. Awesome language, and it uses the Visual Studio toolkits. It's fully integrated into Visual Studio, so you don't need some obscure IDEs to develop with it. And it has also some specific options for content processing in games, and little tidbits that make using the Visual Studio as a tool a bit easier. So that's kind of the top layer of it. If you look at Visual Studio, the tools, the bread and butter, Visual Studio and .NET, what we have here, for instance, Visual Studio is probably the best IDE for developing code ever. So that's the tool of preference. It's awesome we can use that. It has IntelliSense, because if you've never done XNA, you probably don't know the API. And those of you who have programmed anything more know that it's all about the API, especially on managed code. So IntelliSense is something that tells you what you can do with your code. So it basically tries to fill in the blanks. So you don't have to read documentation all the time as you code. That's awesome. So Yeah, that's one. Then we have the integrated build, deploy, debug experience, which means that we don't have separate tools for everything. We can code, build, deploy, debug, all from Visual Studio. So we don't have a variety of tool sets that we have to install and use on every single thing. So it makes it a lot easier, you know, for more productive as a coder, a more pleasant experience to develop. And of course, we can use all the Visual Studio features like build automation, unit testing. All of these are available to us if we want to. So I would just want to point out that this is huge. But let's move on. If we look at XNA itself, how it works, it's based around this really, really simple and widely used idea of a game loop, update and draw. So basically what we have, where most of our code will be in XNA, is in these two simple functions. First, we have the update thing, where we code our game logic. It tells our game world how stuff will update, what physics are doing, how all the animations are going, what inputs are detected, and you know, set variables and do the whole thing. But it won't draw anything, so it doesn't look like anything yet. Maybe it will play some sounds, and that's all. Then we have the draw function, which will run independently of the update loop. And the draw loop will draw anything that's on the scene. So they are separated from each other, which means they are multi-threaded from the get-go. You can have different FPS than, let's say, the physics intervals right from the start. Like, that's how you use XNA. It's really simple. It makes your code better. It's easier to maintain. And if you haven't done a lot of programming yet, that kind of tries to take you to the right path. But anyhow, that's the core of it. You update something, you draw it, and rinse and repeat. Kind of simple. And just to note, on Windows Phone 7, all of these best practices we have used on XNA for years now, they are all there. So the phone environment, the Xbox, the PCs, they all work in the exact same way with the exact same code, which is awesome. And a huge point of XNA, it's multi-platform. So you can, we have something that Microsoft calls 3 screens at the moment. We have your computer screen, we have your living room, awesome big-ass TV, and then we have our mobile devices, which are becoming more awesome all the time. And we can use XNA with the same code and the same code base to build to all of these. And I'm going to show you a multi-platform demo later on, but just to keep in mind, if you develop something awesome for the phone, you can probably quite easily transfer it to the Xbox if it's successful or if it's just too awesome not to do, in my case, usually. And just to give you a basic overview on how it actually works, especially those of you who have never ever seen XNA, I'm going to show you a short demo. So I want to write a program that hooks up the GPU for hardware-accelerated graphics. And I want to load in a sprite, a 2D image, and draw it on a black background. So that's kind of the hello world of games in a sense. So I'm going to do it, and I'm going to do it right now live by opening a blank Visual Studio, selecting a new project, a new XNA Game Studio 4.0, default names, whatever, and go. Just to note, I have the April refresh tools installed. There's a slightly newer version called the beta, which you can get, and it'll look a bit different, but it all works the same. The code's exactly the same, in my examples anyhow. So what we have here is so-called empty project. Well, as you can see, it's not really empty. There's a lot of code there. We have some files, whatnot. First, really fast overview. On the right-hand side, we have the Solution Explorer, the files of our project, and in the middle we have the actual code. What I have opened here is something called the game1.cs. It's the basic file. It includes all the stuff we'll use at the start. I'll make it a bit bigger. And a fast overview of this file. First, we have the using statements. Yeah, we have the framework itself, all the little components we can enable, disable to optimize it a bit. We have the namespaces, the actual game itself, and we have two really interesting things called Graphics Device Manager and a Sprite Batch. Well, if we try to remember our step 1, initialize hardware accelerated graphics, well, we've done it. Because the graphics device manager is the little object handling how our GPU hooks up, what are the resolutions, where are the windows, how are they updated. It's all there, and it's done already. So scratch that. It's awesome. And we can also use some settings here, like, for instance, the default frame rate is set by to 30 FPS, and we have the default resolution set up. We could change those. We can actually support multiple resolutions for different devices, whatnot. It's just a few lines of code there. And we have set the content manager to loop content from the right directory. Then we have something curious called the initialize. Whenever your game starts up, it will first call the initialize function. It's meant for you to set up your game world. Like, if you think about it, when you see the very first frame of the game itself, it already has tons of things going on. You have possibly particle emitters, you have sound, cutscenes, you maybe have controls, characters moving around, a huge ass, wide sandbox environment in front of you. So all that has to be loaded. It has to be set up to its place. Animation B, start, play audio X, background music on. That's where you do what you do in the initialize function. And the base.initialize call, in the end, it actually hooks up different kind of timers, the graphics themselves. So that's what we have there. It's kind of useful, especially if you want to reset your game. You can just initialize it again. That's awesome. Then we have something called load content. Quite simple. It's used for loading in game assets. It's done inside initialize. The base initialize actually calls the load content function. There's a slight difference here. They are both only called once, but initialize is for setting up the game world. Load content is for loading files from the hard drive. So it's a different action. It requires different kind of processing power. That's why they're in different call, and this is kind of an optimizing thing. Also, it makes your code a bit more maintainable if you use it. Then we have the unload content. Quite simple, not going there. We won't use it today. And then we have the update and draw loops. So that's about it. Simple mechanics. And remembering what we wanted to do. We want to draw an image. So first off, we need the image to be drawn. So let's add it. First, you can see we actually have 2 projects here under the solution called Windows Phone Game 1. We have the actual solution, Windows Phone Game 1, and then we have this Windows Phone Game 1 content, a separate project. So this content project is the place where we will import all our stuff. There are 2 projects because if we go multi-platform, we will have multiple projects for each platform, but they all share a single content project. So that's really useful. You don't have to reprocess all your content multiple times. So that's the actual content pipeline project. So how do we import stuff? Luckily, I have my image here right on the desktop. So I'll just take it, try to navigate back to the right window, and drag and drop. Done. Now if we select the whole thing, we could actually go to properties, we could edit how it's processed, but the main thing we need to do or know at this point is that when we build this whole thing, it will read the file, it will convert it into a runtime binary format, and it's all available for use to us. So we're pretty much done with. So now that we have the actual image in, we just need to load it into the game. First off, let us set up a simple variable for it. Text 2D, let's call it, I don't know, XNA. Cool. Now that we have the variable, we actually need to put something in there. So that's called loading content, right? We are going to say that this XNA image is content. We're going to call the, content manager and tell it to load something. And the something will be a texture 2D, and it will be named XNA. And this is actually quite important. The name is just XNA. It's not XNA.png, because in runtime, all the images, all the models are in runtime format. It doesn't care which format we put in. If we can import it, it'll work. So hopefully, now we have image loaded into memory, and we only have to actually call it. I think I missed a semicolon there. So in the draw call, we're going to add some drawing code. In this case, we will initialize the sprite batch. We had something called sprite batch earlier. So let's just call sprite batch.begin and sprite batch.end. Sprite batch is a handy piece of code that's meant to combine all your different images into one sprite batch before turning it over to the GPU. So if you think about it, every time you call the GPU to draw something, it includes a draw call, quite simple. And that draw call takes a certain amount of time. So if we have 100,000 images, it'll take a really long time just to explain the GPU what it has to do. So that's why we have something called a sprite batch. It's like a folder where we can put a lot of sprites in, close it down, and deliver it in a one call. So it optimizes our code so we can literally show 1 million particles at the same time if we're running for the Xbox, for example. So in this case, we want to just say sprite batch.draw, and we want to draw this XNA image. Where we want to draw it? Well, I'll say we'll draw it in the upper left corner, so let's do .0. I hate my laptop keyboard. .0, and we're going to draw it white, which means it's transparent. It won't tint it to red or anything. So there we go. And actually, we wanted a black background, so I'll just like here. And hopefully, if I haven't messed up really badly, it will now deploy to the emulator, which I have open here. Start it up, and there we go. Image, black background, alpha channels. It's been alpha blended, so we have the nice opacity from the Photoshop. And actually, just to prove it, I think it's a lot more awesome. We can actually make the black something more manly, like pink. Turn it over, deploy. Notice the building time. It's like done, and the deployment actually takes a lot longer than building the whole game. And there we have it. The pink XNA came from outer space. That's awesome. So this is what I want to kind of highlight. We took the hardware. We actually have it on the emulator. We could have it on a real device. A few lines of code. I don't know if you were counting, but that was like 8, I think, or something nearby. Quite simple, and that's how you go. Then just add input and whatnot. So moving on, now that you know the real basics, we can take a closer look on the platform, the hardware itself. .NET on Windows. Especially here in the Assemble audience, people are usually kind of itchy about using lower level languages like assembly to write their stuff because it's potentially more optimized for anything, it runs faster, and takes a shitload of time to write because it's usually hard. So .NET on Windows performance side, it's actually really quite fast. It's only a few percentage away from using the C++ native code, and that's if you optimize the hell out of the C++. And that's mostly because there's a really awesome and fast garbage collector running on Windows. It's really fast. And if you really want to take a look at the performance, there's a link to an interesting performance shootout by 2 bloggers. They decided to make this really simple software, one written with .NET, one written with C++ for Windows. I think it was some sort of translator check. It had some, an encyclopedia or something. It parsed and put into a file, and they timed the whole process, how long it took to make it. And to cut the really long story short, they had multiple iterations. They tried to optimize the software to beat the other. And the C++ software took many weeks of optimizing long nights of coding, and it came out faster in the end. But the workload it required was 10, 20 times more than the native version, I mean the managed version. And actually, the managed code version was faster in the start. The first rewrites, the C# version was actually faster, and that's because it's been optimized under the hood. So yes, C++ is faster on Windows, but only if you really, really, really know how to optimize it. And that's not something we as programmers usually have time for. Well, take it as you will. That's how it goes. Then, if you look at .NET on the Xbox 360, there's a lot more significant delta on the performance. And that's because of the different CPU. The Xbox has, if I remember correctly, 3 PowerPC cores run into 2 threads, so like 3 virtual cores. And it's been designed not to allow external code because it's like a gaming device. They don't want hackers going into it. So the cheated code poses a lot of challenges for the processor, but they've done it. It runs, but they can use only the compact framework, which means the garbage collector is slower. So the main thing you can really fall for is to try to fight the XNA nature and forget that there is a garbage collector. There are some automatic things that will run, and you can't escape them. You can't somehow recode the lower level systems. But if you code your game so that it actually works well with the garbage collector, it will run really, really fast. So only a few things are slow, others are blazing fast. But on the Windows Phone 7, how does it go? Well, it's somewhere in between in performance, because now we have the new ARM7 CPUs. They are a lot more forgiving on the CPU architecture, but we still have the simple garbage collector, the compact framework. So if you're looking at how closely you can match the native performance or the supposed native performance, it's really quite there if you know how to do it. But I'm speaking about multi-platform development, but what does it look like? Because I know that on some platforms, developing for multiple target devices can be a real pain. I mean, a real pain, depending on the tools itself. So I actually have a simple demo just to show you how it works. So here, I have a really, really simple game-like experience. It has a few features I want to highlight, and I've made it to target multiple devices, just as a proof of concept to myself. So as I said before, we have something called a multi-platform game here on the Solution Explorer. Then we have the Windows copy of multi-platform game and an Xbox 360 copy of multi-platform game. So when I was doing this, I actually created a really simple game-like thing for the Windows Phone emulator, and actually right-clicked the whole project and selected Create Copy of Project for Windows and Create Copy of Project for Xbox 360. So it cloned the whole thing, and it keeps them synced. So if I modify some files, it automatically transfers all the changes to the other projects. So I haven't done any changes to the other projects. And it uses the same general content project. We have the music, the sound effect, and a few sprites. So let's check it out, what it's all about. It should build the emulator version first, because it was selected. Yep, deploying done. So what we have here, we have a background image, a few chips, background music. It's an MP3, by the way. It eats MP3 files. We can use our awesome touchscreen to navigate one of the ships, and if we actually collide with the other ship, collision detections and a sound effect. That's like a really basic thing. Reaction, input, graphics. So looking at how it works on different platforms, if we deploy it for Windows, unfortunately I don't have an Xbox here with me, but it works actually the same. So yeah, let's go for debug and new instance. it'll build the Windows version of it. Same thing, but notice, different resolution. So it's been somehow modified to fit my desktop experience better. I do have the multi-touch input on my touchscreen. I have some keyboard input. I can use my arrow keys to fly. I could actually use the Xbox 360 controller configured with it, so I can use the dual stick analog controls, and I can of course reset the game and play, experience the awesome as much as I want. But that's the thing. You have to modify it a bit to fit different platforms, because as you could see on that game, I actually had the background image stretched because that's what I chose. But the ship's starting positions were different compared to each other on different platforms. And also, when you're creating the game, the inputs will be different on each platform. So if you think about it, developing for phone environments where you have a touchscreen will require some sort of magic if the original game was designed for a gamepad. Okay, you can have virtual joysticks on the screen, but has the game layout been designed so that your thumbs will cover part of the actual playing area, for instance? So those are the questions that are not XNA specific. They are something you have to address as a developer on all the platform changes. But with this one, it's kind of neat and fast. And I just want to show you a quick overview on how the inputs were done for different platforms. So just so you can see what it's all about. Basically, we can use these commands like if Windows or Xbox, if Windows Phone or Windows, and choose some code that will run only on the target device. Like we have 4 lines of code for the whole arrow key movement thing. We have like a few lines of code to access the whole touchscreen on all of the devices. And then I just choose what parts of the code to be run on a certain device. Couldn't be simpler, pretty much. So I have made some modifications to the input part, and also I have fast mods on the resolution settings. So these are the 2 things you have to configure for every platform. Otherwise, it's completely the same code. The same code will run optimized on each platform. So yeah, moving on. That's kind of the bread and butter. So something I wanted to highlight, which I kind of demonstrated on that demo, we have some cool media features now added to the XNA 4.0 release. We can access the user's music, photos, and video libraries, of course on the phone, like you'd expect, but also on the desktop versions and whatnot. Like the sound I was just playing, it wasn't some proprietary, some XNA music player. It was actually the Windows Media Player playing it on the background. I can control the user's Windows Media Player library on the phone, on the desktop from XNA because it's all integrated. And actually, some really cool features I want to highlight with XNA 4.0. You can now stream music from the URLs from the internet, so you can kind of make a bit smarter, more dynamic apps than before, which I'd like to be. I'd like to see them used in some context, in some games. It could be probably quite awesome. Yeah, moving on. Graphics. That's probably interesting to most of you. In the current version of the Windows Phone 7 XNA 4.0, we don't have configurable shaders in a sense that you can't write your own shaders to the phone. And the main reason is because they wanted to make sure that the current 5 shaders there are work really, really well. And that said, the XNA team has made these 5 shaders that you can use and configure to your own needs. And they will probably cover most of the things you want to do in your average games. So I'll show you a demo of those. And of course, we still have the 2D sprite drawing things, which is also, by the way, a shader effect with pretty much free alpha blending due to the way it's done. So you can draw a shitload of alpha blended awesome sprites, and it'll probably run just as fast as normal sprites without the alpha channels. So another demo. And this one I'll actually show running on the Windows version because this older toolset had a problem with external screens and 3D graphics. But it's the same thing. So we have the basic effect shader. And this one is actually meant for drawing 3D models with lighting. If you're really interested on performance, we do have one device available here in the assembly. So come to me after the thing and I'll show you the real-life FPS. But we can choose. We can have one vertex light, 3 vertex light on the basic lighting rig, and we can have you know, pixel lights, so it'll run better if the model is smaller. If we have to shade less pixels, but it looks slightly better in a sense. But yeah, so you can actually test it out here without any lighting. And then we have the alpha test effect, where we can actually render it once using the vertex light and then clone it to fake like masses of tanks in this example. Or it could be a lot of buildings, a lot of animated models. So we can fake the whole thing, and it could be a multi-million polygon scene with, in reality, only a few hundred in place. Theoretically, at least. Then we have my favorite, actually, the dual texture effect. This is what I think is the most important, but that's my opinion. So we have a simple scene where we have a texture and a light map. So that's like the whole scene. We have a 3D model. Looks pretty dull. I mean, you can't even see the forms. When we apply the texture to it, okay, now we can somehow make out the shape, but it still looks kind of awkward. But when we apply another texture of pre-rendered light maps, I'm sorry, the input's a bit off, we can actually pre-render with, let's say, 3D Max, our supercomputers, a really complex lighting model, and then bake it into a texture and apply it to the scene without using any rendering power on runtime. So we can actually make out really awesome looking 3D scenes with complex shadows and lighting if we don't need the lights to be dynamic. So we have a shader to support that kind of actions. And then, of course, we have the skinned effect. We can have a full-blown skinned, weighted, animated 3D model running on the phone with the skin texture effect. Looks kind of nice. A dude. And of course, we have the environment map effect, which is also cool. So the picture on the background was actually taken by one of the XNA team members, Sean Hargreaves, who wrote the demo himself. And the background picture has been wrapped around this object. And there are these really handy sliders. I'll minimize them. So there's the actual basic object we had. Then we can apply the environment map. You can see it turns all chrome-like as it starts to reflect the environment. We can apply the Fresnel lens shaders to make the material somewhere in between so it doesn't go all chrome-like. And then we can add some specular maps to it. It's actually just a black image with white dots in it. So it gives you the effect of having a lot of small lights around the object. So configuring these, you can go some lengths to create the material you want for the car metal textures, or maybe the furry friend of yours, some dog or whatever. They need to have a different shader configuration. So you can use these to create the material effects. And I'm going to skip the particle one because it's more about performance. So yeah, there we go. We had a few shaders of our own. And actually, because I will show you a really short version of something small I've written myself. So it'll deploy on the actual emulator, where I use the basic effect shader to shade a 2D scene. Yeah, it'll take a minute to deploy. So the basic effects can be used to shade, let's say, primitives or other more simple stuff, like here we have some sprites on the background, and I can use my touchscreen to spawn an awesome amounts of particles and give them orders, fly them around, all additive blended on real time. We can have quite a few on the actual phone itself before it starts to slow at all. So that's something small I tried myself to apply these rendering effects to simple 2D stuff. So just a small demo, and back to boring slides. So there we go. That's how we draw graphics on the platform. Next up, something huge, the live services. So this, I want to spend some extra minutes with this one. You can actually hook up a deal with Microsoft and have your game have the game include the gamer tags, the friend system, the avatars of the players from the Xbox 360 realm. You can even have achievements. You can award gamer score to players if you attain the deal with Microsoft. And the live services will be on a premium spot on the marketplace, the Windows Phone 7 marketplace. So there will be normal categories, and then we'll have the live games. You know, the premium stuff, buy these. So that's to combat the huge saturation of the App Store if you look at the iPhone world. So you can actually have your premium stuff on a premium place without having a multi-million-dollar investment behind you on marketing or a huge brand to drive you. And I wanted to talk about the marketplace itself because this is something I hope you take to heart, especially if you're students. Because if you look at the App Store, how it went when the App Store first came, and the sales figures and who was there, how did they do, the first comers who were there in the gold rush, they actually made tons of sales because there weren't so many competitors at the time. Then after a year or so, even after 6 months, depending on the player, the big names started to come in. They wanted to bring the Call of Duty genres, the Waldo games and whatnot. And nowadays, if you make a game for the App Store or similar, it's really hard to get any attention out there because there are like 30,000 games available and 500 every day or something ridiculous like that. On the Windows Phone 7 market, it's completely a new marketplace. So it's again the same thing. People will buy stuff because that's what they do. They want to toy with their new device. And what's available to them at launch date will sell hotcakes compared to in 6 months of the launch or whatnot. So that's a real thing. We have the live stuff, we have the normal marketplace, and they're both clean at the moment. The device will be out in December or something. So I think it will be a gold rush, and I hope a lot of Finnish guys will somehow take hold of it. Yes, and the last topic I wanted to really cover is productivity versus control. So it's again about the optimizing thing. Because this is what I hear a lot. People want to code native, they don't want to code managed. But through the history or the evolution of programming, there's always been the same discussion, always. Is it either low-level control, straight in the middle, raw performance, or higher level of abstractions, relying on compiler and the runtime code, productivity, is it important, or do we have to optimize? It's always been the same. Even when we were coming up with C as a language, people from the SNES era were kind of itchy on, is that C really, what, do I have to do it? You kind of lose something when you move on from assembler to C, you can't really deal with registries, and I'm not sure what's going on with my code. Yeah, sure. Nowadays, does someone really use assembler to create professional products? No. Why? Because it's a pain compared to programming with C, or C++, or whatever. And again, moving from C to C++, we had object-oriented programming. And again, people were all around like, can we use objects in games? Because games really need all the performance, and we don't need to use objects and blah, blah, blah. Nowadays, nobody does a big architecture without using object-oriented programming. It's like the de facto, everyone does objects, like insane hierarchies. So this just one jump again, to rely more on the compiler, more on the runtime code and less on raw performance on the device itself. And that's a good thing, because nowadays it's also a lot more complex to know the hardware itself. So we should rely on the Microsoft guys to really optimize the hell out of XNA on the platform, so we can learn how to do XNA properly. So that's kind of the end point. And also, if you want like proof of concept, there are, at the time of writing, which was a few months ago, over 800 titles out there on the Xbox done with XNA, on the XNA indie games and whatnot, and they're really good looking. They have great performance. So you should check out those if you're really interested. But just so you know, the Windows Phone 7 series, again, only accepts Silverlight and XNA. There's nothing else. Only C# code, only managed code. So at any case, you're on the same level with other developers. And I really want to stress this one also. XNA is not a new thing. It's version 4.0, which means there were 3 versions before it. And also the .NET 4.0. It's been around for a long time, so it's like the 4th iteration on stability, performance, usability, productivity. It's not the version 1 release. And I've been using it for a few years now, and it's only going up. And some people come by and ask if Microsoft really has an investment to keep this XNA thing going on, or if it will just die tomorrow. No, it won't, because the whole thing, the whole Windows Phone environment is built around the XNA thing. So that's a commitment. They have a lot of power behind XNA, and it will be there tomorrow and the day after that. But a few tips for the newcomers in the end. If you want to make the game, you will probably run into some performance issues at some point, or otherwise you're not doing it right. And here's the basic golden rule of optimizing a thing, aside from not doing it. So it's always a balancing act with choosing how many pixels we have, how often we want to update them, and how long it takes to update a single pixel. So these are kind of the variables we can change. The frame rate, the phone always goes with 30 FPS. We can't make it go any faster, so there's no point in trying to draw any faster. We could do it lower, but I think we want to stick with 30. So you don't want to change that. So what can we change? We can change the pixel cost. Which shader do we want to use? Do we need vertex lights? Or do we need pixel lights? Can we go for a cheaper effect to really achieve the same kind of feeling? You don't want effects, you want feelings in the game, how the user thinks it looks, not how it looks. Can we somehow make it go cheaper by the pixel? And one, of course, is to minimize overdrawing, because a lot of, especially newcomers, tend to draw overlapping sprites. Like we have this animal, and it's flying over the background, so they all draw the background and then the animal on top of it. So you can make some opacity tricks like the X-ray mode to check if you have multiple overlapping sprites. Easy things, just to bear it in mind. Try to draw the one pixel only once, or whatever. And then, of course, we have the number of pixels. The default resolution for the device, and apparently the only supported resolution for now, is the 800 × 480, but we can actually use virtual resolutions on the device, because it has a hardware scaler chip. So we can, in XNA, drop the resolution and radically drop the amount of pixels we have. And depending on the game, it really probably doesn't need all those pixels. It doesn't have to be that crisp, in a sense. If we have a trade-off of having twice the content on the screen versus twice the resolution, I'll go for twice the content. And just as a proof of concept, if you look at modern Xbox games or PS3 games, they all support, in technical levels, the 180p, the full HD resolution, but only rare games actually do it. They usually run on the 720p, normal HD ready resolution. And that's because A, you didn't know it, so who cares? And B, they can have twice the amount of cool stuff on the screen. So it's the same choice here, and I personally think most will go for more content. But it's your choice to make. in any case. And just to mention, with the scaler, we actually have the orientation support. So as the device turns, it can modify the virtual resolution, so your upper left corner will actually be the upper left corner depending on which orientation the device itself will be, and it will translate all the input codes for you. So you can, if you want to hard code it to some specific resolution, the inputs or whatnot, it'll probably work on all the resolutions. And of course, it's free. If I didn't mention it, the hardware scaling is free. It actually takes no performance hit. In any case, it's hardware. Cool. So, as a summary, what we have here with Windows Phone 7, we have quite a powerful platform. I mean, it's a Snapdragon chipset. It can run shitloads of polygons or whatnot. It has a really nice touchscreen, like you all probably know by now, as they're becoming more accessible. And with XNA and the Visual Studio environments, we have really productive tools for making stuff. So prototyping, especially on the mobile world, is really important to get it right, to get it feel right. So with XNA and whatnot, you can actually get it running really fast before deciding if you want to go into it full on for multiple months. And it's portable, because myself, I will be doing some prototyping on the phone itself, and if it sells, hypothetically, I will be interested in transferring the experience to the Xbox Live Arcade. And I can actually do that with the same code base, by just translating the things, making a new UI, but keeping all the game logic code there if I have been thinking about it beforehand, and I will. So that's something to bear in mind. It has a future, in a sense. So resources, where to find more? You can ask me. You can come to the Microsoft booth to fiddle around with the Surface and whatnot. We can talk more about the design of the phone itself, how it works, what's kind of the mindset of Microsoft, why the phone is there. We can talk. I can show you some more demos. We have all sorts of cool stuff if you want to know. But for websites, creators.xna.com. That's where you can download everything for free. XNA is free. You don't need to buy anything to fiddle around with it. Codeplex has a lot of cool open source stuff, 2D physics engines, 3D engines, you name it, it's there. The Sean Hargreaves blog, who made the 3D example, he's one of the main guys behind XNA, and he has a really, really in-depth blog about the technical aspects of XNA. So if it's not there, you don't need to know it. And of course, there's a free ebook out there, a draft version of how to program for Windows Phone. I think it was something like Windows Phone programming for dummies or something. So it's a good read if you want to, a free ebook, go for it. And just to mention, the publishing in the App Store or the Microsoft Marketplace, whatever, it costs the same amount as for Apple, but for students, it's free. Free. That's cool. So that said, please go to developer.windowsphone.com, download the tools, create some awesome stuff, mail them back to me so I can just see them and go nuts, because I'm really interested in the stuff. And thank you for your time. I think we have like half a minute for questions or something. So if you have something quick, please raise your hand. There's one, so please wait. We'll have a mic in a second.
How much do the... Is this on?
Yeah, it's on. Go ahead.
How much do the tools cost?
Which tools?
Like Visual Studio and stuff like that.
You can use the Visual Studio Expression set, so free. But also you can use the professional versions, and if you're a student, free. Again. But of course, for professionals, you can use any, if you have team systems, go for it. But if you don't, just download the free versions, and it's exactly the same. Anything else fast? No? OK. If you have any extra questions, please come to me after the show, come to the Microsoft booth. But otherwise, thank you for coming.